Hello students, welcome to Young Cubs. Today is the last lecture for linear functions. Okay, so let's start. An art gallery has a small plot of land with 10 sculptures. The sculptures are shown as points on the grid below. The distance are measured in meters. Okay, so there are 10 of them. The gallery is building a rectangular enclosure to keep the sculptures safe. So it's building a rectangular enclosure. It is planning to build straight fences along the lines y is equal to 160. Where is y is equal to 160? It's this one. Y is equal to 160. It's this line. Okay. Then y is equal to minus 140. So below 0, so this is y is equal to minus 140. Yeah, x is equal to 210. So where is 210? It is 50, 200, this one right here, this one, 210. Okay, and then x is equal to minus 190. Minus 190 is here. Here. Alright? To form the rectangular enclosure, would any sculpture be outside the enclosure? Justify your answer. So if that's the enclosure, if that is the enclosure, I have 1 point over here which is outside. So my 1 point which is 220 by 80 is out. Then I have this one which is minus it's minus 100 by 200. What is the next one which is out? I find this one out as well, which is minus 200 minus 40. That's it. Let's see, is there any, if they can we find any more? So we found 220 by 80. Yeah, that's it. 3 points outside the enclosure. Alright. What's the, or now they're saying that justify your answer. Justification is simple. I'll just write these numbers down. My first enclosure is minus 200 and no, it's 220 and 80. Then the second one is minus 100 and 200. The third one is minus 200 and minus 40. The simple justification is that the points or the sculptures lie beyond the lines. In bracket I'm going to write equations. Alright. Give the equations of the fence lines which would form the smallest possible rectangular enclosure that has all 10 sculptures inside. Assume a sculpture can lie on the fence line. Okay, so that means if I have to take this one, so I need to have this as the line out here. This one. Correct? So that one is, this is y is equal to 200. That's going to be my equation over there. So one is y is equal to 200. That's one equation, one line. What's the second one? Then this one, if I take this one, okay, so it's going to be my x-axis. So my x-axis is going to be 220. Correct? So y is equal to x is equal to 220. I'll put it here. Third one. X is equal to 220. Let me look for another y. So smallest enclosure, that means this is 120 out here. So it's going to be y is equal to minus 120. Correct? And the fourth one, it's an enclosure, a rectangular enclosure. So on this side I need this line. So it's going to be minus 200. So x is equal to minus 200. That's going to be the smallest enclosure, assuming that the sculpture can lie on the fence line. What is the area of the smallest possible enclosure that gallery can build? So we have to find the area. So now children, we will have to calculate the distance between 2 points. So starting from point 0, this is 50, 100. Assume 1 second that the gallery can be built. Okay, so 60, 100, 50, 100, 150 and 200. So we have 200 and we have 50, 100, and this is how much? This is 120. So plus 120 gives me how much? 320. So the length, if I assume that this is the length, my length is 320. Okay, and let me check for the width or the breadth. Okay, my breadth out here will be calculated again from 0. So 50, 100, 150, and how much is this? We need it here on this line. So it's 200. So we have 200 on one side, and 50, 100, 150, and 220 right here. So and 220. So my answer is 420. So my width is 420. So area of a rectangle is equal to length into breadth. My length is 320, my breadth is 420. Calculating it on the calculator, children. 320 into 420 gives me 134,400 meters square. They have mentioned it that the distance or the entire area is in meter. So the unit for area is meters square. Let's go for the next sum. The grid below shows vertical lines V1, V2, V3 and V4 with equations x is equal to 8, x is equal to 16, x is equal to 24. Alright. So look at the, just basic clicking in the head that the distance between two vertical lines is 8. So this is 8 ones are 8, 8 twos are 16, 8 threes are 24. Alright, so the table of 8. And here it also shows horizontal lines H1, H2, H3, H4 with equations Y6, Y12, Y18 and Y20, Y is equal to 24. So here the difference, horizontal lines are at a distance of 6. So the table of 6. So I'll just put this down. V1, 2, 3, 4. So only 3 have been given, or fourth one, so it's assumed fourth one is. So this is 8, 16, 24, 32. Alright, yeah, it is 32 as per the graph. Look at this point, this is 32. Alright, assuming the sequence of equation of horizontal and vertical lines continue as shown, deduce the equation of lines H10. So if 1 is 8, okay, H10 and V15. So I've drawn the table for convenience for vertical and horizontal. So I'll start 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So going by the table of 8, so 8 ones are 8, 8 twos are 16, so 8 15s are 120. Alright, so what is the equation of the vertical line? So vertical line depicts X, so X V15 equation will be X is equal to 120. Alright, so now let's look for H10. Okay, it's going to be Y is equal to, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first one was 6, 12, 18, 24. So by 10, 6 tens are 6 ones are 6, 6 twos are 12. So for 6 tens are 60. Alright, so my equation for the Y is equal to, my equation for H10 will be Y is equal to 60. What are the coordinates of the point of intersection of the lines H20 and V30? So V30, that means 8 into 30, correct? Because we know that it's going by the table of 8, correct? So 8 tens are 80, right? So V30 is going to 8 threes are 24, so 240. So that's my X equation. X is equal to 240, and what is my H20 going to be? 6 into 20, which is 6 twos are 12, 120. Okay, which is going to be my y-axis. So what is the point of intersection going to be? 240 by 120. Isn't it very simple, children? That's all for today, children. Thank you and God bless you all.